Good evening and welcome to our first tutoring session here for the kids. If you're struggling a little bit with the greatest common factors, this is to help you out at home there. Our first video is on greatest common factors and how to find them. First, we need to define what a greatest common factor is. When we take a number and look at the numbers that multiply into that number, those are what we call factors. So, for example, if I have the number 4, the factors of 4 are 1 and 4 because 1 times 4 is 4, and 2 because 2 times 2 equals 4. So, simply put, it's any number that will multiply into a number. When we're finding the greatest common factor, what we're actually looking at is what are the numbers, or of the numbers, what is the number that is the largest number that will go into two separate numbers. And we can find that two different ways. The first way is something I'm doing with the kids called the T-chart, and I'll pause for a moment to show you an example of that. All right, so I hope you had a chance to look at that T-chart. The general idea is it allows us to put the two factors we're multiplying together, one of them on the left side, one of them on the right side, in an organized manner. So when I take my T-chart, what I'm going to do is I'm going to put the number that I'm trying to find the factors of up at the top, and I will do that for you right now. Let's take, for example, the number 10. So on my T-chart, I will put a 10 at the top. The key here is organization, and I've been working with the kids on that. You can't just start guessing at factors. We work through a method. So I'm not going to start with 2 or 3 or 4. I'm going to start with the easiest of all the multiplication here, the identity property, the number 1. So we will start with 1 times 10. On the left side of the chart, I'll put the 1, and then the 10, because that is the other factor I'm multiplying by, will go on the opposite side. So we get the 1 on one side and 10 on the other. Proceeding then, and again, we said it was organized, so we're going to do it in an order. I then ask myself, is there anything times 2 that will also give me 10? Because that would make 2 a factor. And of course, 2 times 5, that is a factor, or those are factors of 10. So I would proceed to put a 2 on that left side and a 5 on the right side. Now there's something I want to point out here, and I've shown the kids this. As these numbers are increasing on this side, these numbers are decreasing. We're actually working toward a center point where you can say, yeah, I'm about halfway to that number and there are no other factors. Eventually what would happen would be this side would eventually become this side as it's going down. In other words, they will actually flip. We call that the commutative property. We're allowed to flip a multiplication problem so the numbers are in a different order. We are allowed to do that. And so that would show up on the T-chart, but thankfully we're just looking for the factors. So once we reach that middle point where the next number is going to take me to numbers I already have on the right side, then I'm done. I found all the factors. So we continue on. We say, okay, well, will 3 be a factor of 10? 3 times 3 is 9. That's close to 10, but not 10. Is 4 a factor of 10? Well, there's nothing I can multiply 4 by that will get 10. 4 times 2 is 8. 4 times 3 is 12. So 4 is not going to be a factor of 10, excuse me. Then I try 5, but 5's already on here. So I am done, and I can look at these factors and say, all right, the factors of 10 are, and then I can list them. They are 1, 2, 5, and 10. Those are my factors of 10. Now, we said we were going to talk about greatest common factor, though. Well, in order to talk about greatest common factor, we need to deal with more than one number. I have 10 here, but in truth, to deal with greatest common factor, I would actually need 2 numbers. For example, 12 and 18. I would find the factors for 12 and 18, And then I will do my comparison to find the greatest common factor, the largest factor both numbers have in common. I'm going to pause for a moment, or you can hit pause on the YouTube here for a moment, and I will let you try to work out 12 through 18 as I work them out, and then we'll compare when we come back. How did it turn out? Hopefully you hit pause at this time and you were able to work out 12 and 18. Let's compare them right now. If you've still not done 12 and 18, I would recommend you hit pause right now. I'd like you to at least try them, and then when you hit play again, we can compare our factors that we came up with. Give you a moment. All right, here's what I came up with. For 12, using the identity property, I recognize that 1 times 12 is 12. The identity property, again, meaning that if I multiply a number by 1, it's going to keep its identity. So 1 times 12 is 12, 1 times 18 is 18, 1 times 10 is 10, etc. If we just have the identity property and there's no other factor for that number becomes a prime number, which we'll do in a different session. If, however, it is like 12 is here and has multiple factors besides 1 in itself, then it is a composite number, which we will also talk about in a future video. What did you come up with? I came up with 1 times 12. I then tried 2. Remember, we're keeping these in order. 2 times 6. And then finally, 3 times 4. The next number I would try would be 4, but if you look, we already have 4. 1 times 18, that would give me 18 identity property. I then, again, keeping it in order, I tried 2. 2 times 9 is 18. I then tried 3. 3 times 6, 18. I would still try 4 even though it does not show up here. 4, well, 4 times 4 is 16, that's too low. And 4 times 5 is 20, that's too high. I'm still not to my 6 yet, so I should try the next number. But the next number is 5, and we know some rules about 5s. 5s will only multiply into numbers. They are only factors, we would say, of numbers that end in 0 and 5. And 18, of course, ends in 8. So 5 is really not an option here. The next number we would try is 6, and we've already used 6. So we're at the end of our factors. I'll give you a moment to write down your factors as I do the same. How did it turn out? Were you able to write the factors down? Let's look at them together. For 12, I came up with 1, 2, 3, 4, 6, and 12. These are not common factors yet, but these are the factors of 12. For 18, I listed 1, 2, 3, 6, 9, and 18. Again, these are factors, but not necessarily common factors. You will notice, though, that 12 and 18 have many factors in common. They both share 1, 2, 3, and 6. So the question is, how do I choose the greatest common factor when there are so many common factors? Well, it's in the name. When we break down the name, greatest common factor, there are 3 words there, and if we think about what they each mean, that will tell us which number to choose. The word greatest, that means the largest factor. Common means the same, so we're looking for the largest, same, and then these are all factors, so the largest same factor, or number that can be multiplied into both numbers. In this case, if you look at your list, you can see it on the T-chart and on your paper that the largest factor, the greatest one, is 6. So on your piece of paper, we would use the abbreviation for greatest common factor, which is GCF. And we would find that the greatest common factor for these numbers is 6. And we would record it. The greatest common factor of 12 and 18 is 6. Now the question is, why do we need to know greatest common factors? What's the big deal that these two numbers have factors in common? Well, that's going to come into play as we start working with things like fractions. If I end up with a fraction, for example, 12/18, and I need to reduce it to simplest form, which does actually make fractions much easier to understand, I need to know what I can reduce it by in order to simplify this so I don't have to sit there dividing over and over again, but only need to do it one time. For example, if I have the fraction 12/18 with 12 in the numerator, the top number, and 18 in the denominator, the bottom number, and I was told I need to find simplest form because 12/18 is a large fraction, a little hard to comprehend and understand. Well, there's a lot of numbers I could divide them by to find an equivalent fraction, a fraction that stands for the same amount, but using different numbers to show that. Well, 12/18, for example, is showing that there are 12 out of 18 full pieces. I can't divide by just any number because if I reduce the value of the numerator, I must also reduce the value of the denominator by a same amount. Well, that means I have to divide by the same number. By finding the greatest common factor, rather than dividing, for example, by 2 over and over again, which would give me 6/9, and then I would find, oh wait, 3 goes into that, which would give me 2/3. Instead, I would go right to the number I need to reduce this to simplest form, which is 6. 12 divided by 6 is 2. And 18 divided by 6 is 3. And rather than dividing once by 2 and then discovering I then have to divide again by 3 to get simplest form, I have now found the largest number that both numbers can be divided by. So greatest common factor does have a purpose in fractions. There are actually, though, as I said earlier, 2 ways that you can actually find the greatest common factor. In the next portion here, we'll look at the second way, called prime factorization.